Within Zerto, there are 4 different types of sync: initial, continuous, bitmap, and delta. After a VPG creation triggers an initial sync, a replica disk is created at the target site for each volume on the source site. The existing data of each VM is copied by the source site's virtual replication appliance and sent to the target site's VRA, where it is written to the target journal and then committed to the replica disk. While an initial sync is happening, Zerto is also tracking new writes which will be replicated to the target site after the initial sync completes. Continuous sync is the most common type of sync. New writes to the source disk are tracked by Zerto. As the source VM writes a block to the source disk, asynchronously the VRA captures that same block change. Then the source disk sends an acknowledgement to the source VM. The source VRA captures that acknowledgement. Every 5 to 10 seconds, the source VRA will compress those writes and sends them to the target VRA. The target VRA then writes to the journal. When the journal fills up, the next checkpoint causes the oldest checkpoint to flush to the replica disk. The length of the journal is defined in VPG settings and can be anywhere from 1 hour to 30 days. Bitmap sync will occur if there is an interruption to the replication service for a short amount of time. During a bitmap sync, data changes in a VPG will be stored in the source VRA memory in a bitmap. When the connection between the source and target site is restored, the source VRA will send the updates to the target VRA. These changes are then written to the journal and then committed to the replica disk. When this process is complete, Zerto will resume continuous sync. The source VRA memory disk allocated is 3 GB by default, and if the service is interrupted for long enough for the memory to fill up, Zerto will need to do a delta sync instead. A delta sync will be required when an extended interruption in replication occurs. When the outage is longer than the VRA memory for a bitmap sync, then it will trigger a delta sync. The process does not actually start until the connection is restored. When the interruption ends and the connection is restored, Zerto performs a checksum, which compares the data on the source and target disks to determine the differences. Zerto notes the changes and overwrites the blocks on the target disk. There is CPU impact only at the target site. The delta sync only occurs to the replica volume and not the journal. A forced sync of a VPG is rarely used. It is essentially a manually initiated delta sync. A forced sync of a VPG will complete an MD5 checksum of the VPG's data on both the source and target disks. The noted changes will be sent over to the replica disk on the target site. When a VM is reverted to a previous snapshot, it may cause the protected VM's RPO to increase. This may trigger a delta sync or require a forced sync. A forced sync may impact CPU on the target site VRAs. Preceding is a common request where network bandwidth is at a premium. When creating a VPG using preceded volumes, a full initial sync across the network is avoided. Zerto can leverage existing volumes on the recovery site to protect data on the production site. These existing volumes, from any source, i.e. backups or a previous Zerto VPG, may be used to protect new data when the volume is copied to the recovery site. For the precede and MD5 checksum will occur between the existing volumes. Any differences between the production site will be replicated over to the recovery site.